So in the last recording, we talked about the SI unit. Now let's give more examples. I think we end up talking about the pressure. That's not active, now it's active. Pressure. The pressure is defined as force over area. Keep in mind, that could be the pressure or could be the stress, right? Could be normal stress, could be shear stress. So the units of the force is Newton, right? And the unit of area is meter square. So the units of pressure is Newton per meter square. If you want to look to the dimensions, if you are expressing the dimension in FLT system, it will be F L minus 2, right? If you are expressing the dimension in the MLT, you have to remove F and becomes L T minus 2 times L minus 2. So I will end up having M L minus 1 T minus 2. Then a scientist came and gave a name for the combination of Newton per meter square, and we call that actually by the name of the scientist called Pascal. So since now on, you can say, okay, the units of the pressure is Pascal. You don't have to write the full name, but you can just write the PA. And as usual, it's a scientist. As a matter of respect, P will be capital. So far we have Newton, and we have Pascal, and we have Kelvin. These so far are the three scientist names, and we are using capital letter for their units, right? Okay, everything else is going into a small letter. What else? Let's do work or energy, right? Or torque or moment. We said this is force times distance. You want to get the unit? Yes, force is measured by Newton. Distance is measured by meter. So the unit of work is Newton. Let's make these arrows here. Newton meter. Okay. If you want to do the dimension, you can do that in FLT system or MLT system. Then a new scientist name came up that combined the multiplication of Newton times M or time meter, force times distance. We call that actually what? We call that joule. And that's a name of scientist. So when we write the unit, you can just write J capital. So we can actually add joule to this list here. Okay. Then next example, I would say the power, which is simply work over time or energy over time. So it is simply as a unit, the work end up to have a unit of joule. Time is measured by seconds. So the units of the power is joule per second. Then a new scientist name came in to have an equivalent for that unit here. What is the name of that scientist? Watts. So we can write down this as W capital as unit. Again, I said I prefer to always have the unit between brackets. So when you see that, you can distinguish between dimensions and units. Some publication, if you are a researcher, they are using these kind of writing. Others, they just use parentheses. Just different schools of expressing the units. So I would add here watt to the, let me actually fix that. I'm gonna add watt to the list of the units that actually utilize capital letter. So far, these are the only 5 units that utilize capital letter. Otherwise, everything has to be written in a small letter. And I think that's cover all the details about the SI unit or the standard of international unit system, how to use the basic units like distance, time, temperature, and so on to drive or to develop the units of more complex quantities like velocities, acceleration, pressure, work, and power. Then we're going to move to the other existing types of unit systems, which basically the imperial system, or we call that the English system. And the other one is called actually the British gravitational system, which rarely used. In the United States, we are mixing between the use of SI unit and the English or the Imperial units as well. So let's talk about this in the next recording.